Thank you very much. You can see the title is Scientific Cooperation, so that's what I'd like to focus on. And I think there are many of you in the audience here that can help scientists to actually work together a little bit more. And I think we've heard over the last couple of days that the really important thing about the Arctic is there's lots of changes going on. It's been enforced by what's going on outside on the whole, but the Arctic itself is being affected in many, many different ways: currents, ocean currents, atmosphere, weather. And the word that's been used a lot to describe the Arctic is about the complexity of the environmental system and and the human system added to that and how we deal with it. Well, let's have a look at what actually we can do about it physically. One point I think I'd like to say is that one thing that scientists really need to understand is what is happening underneath the sea ice in the Arctic. We've heard that it's shrinking, but we don't really know what's happening underneath because for many years there has been a cover of sea ice and we haven't really been able to get underneath it and have a look. And underneath it now, there are becoming some glimpses of some really interesting ecosystems. Here we go. Underneath the Arctic ice. And I think we really need to sort of focus on that. There's a big knowledge gap at the moment. And imagine what happens when some of those ships go across that are going through the shipping route. And one thing, they're full of ballast. They're full of water that's full of bacteria and small bugs that they're bringing from different parts of the global ocean that potentially can be released into the Arctic Ocean and will interact with some of these biota that we really don't know anything about. So I think understanding what's underneath the ice sheet is really quite critical, a critical science problem in the future. And to work on that kind of thing requires really logistically challenging practical approaches to getting scientists into the Arctic and getting them able to look under the ice. That requires a huge amount of international cooperation. And I think you'll find that certainly on the oceans, there are large ships, scientific ships working on the oceans that have got big multinational crews on, multidisciplinary crews, very expensive cruises, doing quite complex work in those areas. But on land as well, on the tundra, you can go up there and work on the tundra with a tent and just a couple of people. But again, it takes huge logistics just to get into some of those tundra areas. It requires a lot of organisation. I think also the Arctic is a good place where we can pool expertise, scientific expertise, to approach some of that complexity. And here's just an example of a group I worked with a few years ago. There's just 18 people there on Svalbard, but there were 6 nationalities in that group. We each had expertise in a different discipline, and pooling that together made a huge difference in trying to understand what we were looking at, which happened to be rocks at that time, working together. And really interestingly as well, in that group, there were half the people there were graduate students, early career researchers who were learning to be polar scientists of the future, which I think is really important. The Arctic is a fantastic training ground for environmental scientists to take on the challenge of climate change in the future. So scientists like to work together. I think they disregard politics, which I use in the broadest sense. They hate bureaucracy. They just want to get on and do science. And I think one of the things we need to do is make sure that scientists can go out in the field and collect that precious data that we need to have to understand how the climate is changing. And that means across all regions. There are some big areas. If you heard my talk on Friday, I showed a diagram that showed there are big data gaps in what we know about the Arctic. There are people who have been in the field and worked on specific areas and got data from specific areas, but there's an awful lot of the Arctic that hasn't been touched by science. We also need to do long-term monitoring. A lot of science, I think, in the Arctic at the moment are short-term projects that you can get on grants, 2, 3 years, 5 years, even longer ones from IPY projects. But what's the legacy of IPY? We really need, I think, to commit to longer term monitoring. So we really need to know what's happening on a longer scale, not just these short term variations which we've seen, but what is the real trend in the Arctic over the longer time. And I think seasonal data are also something that we're a bit short of. An awful lot of people go to the Arctic in the summer, and it's a hard place to work, but the summer is a much nicer place to be. But here, this is a picture of the Coast Guard ship, the Canadian Coast Guard ship, the Amazon, which was frozen into the Arctic Ocean in the Beaufort Sea in the IPY year a few years ago. And they had a big project called ArcticNet, which was looking at the Arctic Ocean and the Arctic environment throughout the whole year. And that seasonality is really extreme in the Arctic, much more extreme than anywhere else on the globe except the Antarctic. And I think understanding how things change is really important, not only for the changing environment and the weather and understanding climate, but also if we're going to take human beings into the Arctic more, if we're going to take shipping and industry in the Arctic, understanding that seasonal impact is really important. The Arctic is also a fantastic place, well, both polar regions. There's a lot of discussion now about new innovative technologies. And there's all sorts of things that can help us work in the Arctic without having to go up there and do risky things in difficult places. And this is a picture of a ship from the National Oceanography Centre in Southampton. And you can see their array of autonomous vehicles. And that's just a selection of a few that are available now. But we can send these vehicles out into the oceans. They can take measurements by themselves. They can stay there for years until their batteries run out and collect important data. It will be really interesting also to bring people into the Arctic Forum that are not people who are working in the Arctic at present, but who are designers, engineers, innovators who work in completely different fields on Earth and that can come to the Arctic and work with us to really think about different ways of doing science. And not different ways of doing the same science, but actually new science that we'd never thought about. And as I mentioned the other day, I think working in cooperation with industry is actually an ideal place in the Arctic. And I think scientists can help. The climate is changing, the environment is changing, and as industry comes in, they will change it as well. Too rapid changes on top of one another is not particularly a good state to be in. So let's work together to understand how the changes are happening. And something that preoccupies me a lot as head of the British Antarctic Survey is budget, and particularly the fuel budget for going to these places. Ships, boats, planes, they all take a large amount of fuel, which costs an awful lot, or at the moment the fuel price is a bit lower. And the cost of these expeditions is enormous to get to the Arctic. International cooperation really is the way to go, to share facilities, to share ship costs, to share journeys and to share scientific projects. One of the problems at the moment is that if you apply for money to work, to do a big international project, you tend to have to apply to your national grant funder to get grants. And so you can form a really nice international group, and then they all split up and have to apply for funding in their same national pots. And we get into what we call double jeopardy, that one nation receives a grant and gets positive reviews and the other nation fails. And you start having to go through this process so many times that eventually many people give up. It would be fantastic if there was some way that we could change the funding systems internationally so that we could work together more and would get rid of this double jeopardy situation. The EU is a really good funding system. People can do multidisciplinary science across many nations. And actually, the Office of Naval Research, there are some really great projects funded by them that bring scientists together across nations. And there's some really exciting science to be done in the Arctic. And I finish with this slide because nobody's talked about the past in the Arctic. And these are some students who've worked on Svalbard. They're geology students, and they're looking for fossil leaves in the Arctic to show that the Arctic actually, 45 million years ago, was much warmer. There were forests in the Arctic, and the leaves from those forests are preserved in the rock. So you can see a long history of Arctic. It changed in the past, and it's changing again now, but much faster than it ever did in the past, and it's affecting the way we live in that region and on the whole globe. So I think scientists can work together much more efficiently and work together to answer some really big global problems in this region. Thank you.